Hello everyone and welcome back to EverlastCyber. In today's video, we'll be going through some practice questions for the Oracle Database Administration Part 1. We'll be starting right off with question 1. What is the purpose of the Oracle Data Dictionary? A. Store user-defined functions. B. Store metadata about the database schema and structure. C. Execute SQL queries. D. Backup data. In option A, user-defined functions are stored in the database schema, but they are not part of the data dictionary itself. In option B, the Oracle Data Dictionary is a collection of tables and views that stores metadata about the database. So the metadata includes information about database objects like tables, columns, indexes, users, roles, constraints, and privileges. It is essential for managing and querying the database because it provides details about the structure and organization of the data. Looking at option C, the data dictionary does not execute SQL queries. Instead, it provides information about the database objects that SQL queries can operate on. And in option D, the data dictionary does not back up data. Backup operations are managed using tools like export utilities and RMAN. So we'll be going with option B. The purpose of the Oracle Data Dictionary is to provide information on database objects like tables, columns, indexes, and constraints. And it is essential for managing and querying the database because it provides details about the structure and organization of the data. Question 2. For what data storage paradigm must data be normalized? A. Network databases. B. Hierarchical databases. C. Relational databases. D. Object-oriented databases. Network databases use a flexible schema with many-to-many relationships, so normalization is not a strict requirement. Hierarchical databases use a tree structure, and this makes normalization unnecessary. Relational databases, on the other hand, involves breaking down large tables into smaller related tables and establishing relationships between them using primary keys and foreign keys. Normalization in itself is a process used in relational databases to reduce redundancy and to improve data integrity by organizing data into structured tables. In option D, object-oriented databases store data as objects, and this eliminates the need for normalization. So, normalization is essential for option C, relational databases, and this is to maintain data integrity, eliminate redundancy, and ensure consistency. So our answer is option C. Question 3. Which process is responsible for writing modified data blocks from the database buffer cache to the data files? A. SMON. B. PMON. C. Database writer. D. LGWR. The SMON, or the System Monitor process, is responsible for instance recovery, and it does not handle writing data blocks to data files. What it does is that it cleans up temporary segments and it frees up space in the table spaces. In option B, the process monitor, or PMON, cleans up after failed user processes. So it releases resources like locks and memories, and it rolls back transactions. However, it does not manage writing to data files. In option C, the database writer process is responsible for writing modified data blocks from the database buffer cache in the system global area to the data files on disk. This ensures that changes made to the data are permanently saved in the database. This process works asynchronously, meaning that it writes to the data files periodically but not immediately after each change. In option D, the log writer process writes redo log entries from the redo log buffer to the redo log files. It ensures that changes are effectively logged for recovery purposes, but it does not write data blocks to data files. So we'll be going with option C here. The process responsible for writing modified data blocks from the database buffer cache to the data files is the database writer. Question 4. What is the default extension for an Oracle database parameter file? A. .par, B. .ora, C. .pfile, D. .spfile. In option A, the .par extension is not associated with Oracle parameter files. This extension is sometimes used for parameter files in other contexts like data dump, but it is not used for database initialization. In option B, the default extension for an Oracle database parameter file is .ora. This is a text file that contains initialization parameters used to configure and start an Oracle database instance. Looking at option C, while the P file refers to the parameter file, .pfile itself is not the default extension. The actual file uses .ora. And in option D, .spfile, which is the server parameter file, is a binary file that also stores initialization parameters. Its default name is spfile and then the Oracle user ID .ora. But option B .ora is still the extension that is used for Oracle database parameter files. Question 5. What type of relationship should be avoided when normalizing data? A. Many-to-many, B. One-to-many, C. One-to-one, D. Many-to-one. In database normalization, many-to-many relationships should be avoided because they can lead to data redundancy. In option B, one-to-many is common and necessary in normalized databases. In option C, one-to-one is used only when strict relationships are needed and it doesn't cause redundancy. While in option D, many-to-one is similar to one-to-many, so it doesn't have an issue with normalization. Out of these options, the relationship that should be avoided when normalizing data is option A. This is because using this relationship can cause data redundancy and inconsistency. So it's good to avoid this. Instead, what should be done is that they should be broken down into two one-to-many relationships using a junction table or a bridge. Another reason why we should avoid many-to-many relationships during data normalization is that it can cause anomalies in data manipulation, such as insertion, deletion, and update anomalies. Additionally, querying many-to-many relationships directly is very complex and inefficient. So the best way to fix this issue is that we can introduce a junction table that includes foreign keys from both related tables, and this converts the many-to-many into two one-to-many relationships, thus ensuring better data integrity. Question 6. Which of the following is not a valid Oracle database file type? A. Control file, B. Data file, C. Index file, D. Redo log file. The control file contains metadata about the database like the structure, data file locations, and log history. It is essential for database startup and recovery, but it is not a valid Oracle database. In option B, the data file stores the actual user and application data, including tables, indexes, and other database objects. In Oracle database, there is no file type called an index file. While indexes are a valid database object used to improve query performance, they are stored within data files and they do not have a separate file type. Now let's look at option D. The redo log file contains a record of changes made to the database, and this is critical for data recovery in case of a crash or system failure. So looking at these options we have, some valid Oracle database file types are the control file, the data file, and the redo log file. Out of these options, option C, the index file, is not a valid Oracle database file type. Question 7. Which 3 Oracle database space management features will work with both dictionary and locally managed table spaces? In this, we'll be choosing 3 options. A. Oracle managed files. B. Online table segment shrink. C. Online index segment shrink. D. Automatic data file extension. E. Capacity planning growth reports based on historical data in the automatic workload repository. Out of these 5 options, we'll be going with options A, D, and E. The Oracle managed files work with both dictionary managed and locally managed table spaces. It simplifies file management by letting Oracle to automatically create, name, and manage database files. In option D, the automatic data file extension feature works with both dictionary managed and locally managed table spaces. This is because it allows data files to grow automatically when more space is required. Option E, the automatic workload repository reports are independent of the table space management method, so they provide historical data for capacity planning and growth analysis, meaning that they can work with both dictionary and locally managed table spaces. That is why we're going with these 3 options. Question 8. What is the maximum number of redo log groups an Oracle database can have? A. 10. B. 32. C. 255. D. Unlimited. Option A is far below the actual limits. Oracle allows more than 10 redo log groups. Option B, while this is a smaller number of redo log groups and it can actually be used, it's still not the maximum number of redo log groups that an Oracle database can have. An Oracle database can have a maximum of 255 redo log groups. Each log group contains one or more redo log members, and the groups are used in a cyclic manner to store redo log entries. These log groups are essential for ensuring that changes to the database can be recovered in case of a failure or a system crash. So Oracle automatically switches between redo log groups as each one fills up, and then the filled groups are archived. That is, if archiving is enabled. Option D is not our answer because the number of redo log groups is not limited. Oracle imposes a maximum limit of 255 redo log groups. So our answer here is option C. The maximum number of redo log groups an Oracle database can have is 255. Question 9. What is the function of the Oracle alerts log? A. Stores audit records. B. Records database warnings and critical errors. C. Logs SQL execution plans. D. Stores DDL statements. Looking at option A, audit records are stored in audit logs and not the alerts log. Audit logs track user activity and database operations related to security and compliance. The Oracle Alerts log is a crucial log file that records important messages related to the database's operation. It includes information about the database startup and shutdown, warnings, critical errors, and other significant events that may require attention. This alerts log is an essential resource for diagnosing issues and troubleshooting database problems. In option C, SQL execution plans are not stored in the alerts logs. They are captured in the SQL trace files or by using the Oracle explain plan. In option D, DDL or data definition language statements such as create or alter are not logged in the alerts log. They might be captured in the audit logs if auditing is enabled, but they are not typically logged in the alerts log. So out of these options, our answer is option B. The function of the Oracle Alerts log is to record database warnings and critical errors. Question 10. What happens when a commit statement is executed? A. Saves all database changes permanently. B. Rolls back uncommitted changes. C. Frees up space in the undo tablespace. D. Terminates the user session. When a commit statement is executed in Oracle, it makes all changes made during that current transaction permanent. This means that any modifications such as updates, deletions, or insertions to the database are written to the database and they cannot be rolled back. This transaction is considered complete once the commit is executed. Additionally, the undo tablespace is cleared of any changes that were part of the transaction once the commit is performed, so these changes will now become permanent. In option B, a rollback statement does not commit, like it is not responsible for undoing uncommitted changes. In option C, while the commit action allows the changes to be permanent, it does not directly free up space in the undo tablespace. The undo tablespace will be cleaned up as part of the Oracle's internal processes of managing undo data. In option D, a commit does not terminate the user session. The session can continue after the commit statement is executed. So out of these options, what happens when a commit statement is executed is that it saves all database changes permanently, and this is option A. Question 11. Which three are types of segments in an Oracle database? From the question we already know, we'll be choosing two options. Option A, undo. B, index. C, stored procedures. D, sequences. E, tables. The undo segment is used to store undo information, and this allows transactions to roll back changes, as well as provides a read consistency for queries. An index segment is used to store index data that helps speed up the retrieval of rows from a table. Each index in a database is stored in its own segment. In option C, stored procedures are not segments. They are part of the PL SQL code that is stored in the database, so they don't use segments. Sequences are also not segments. They are objects that generate a sequence of numeric values, but they do not consume storage in the form of a segment. A table segment is used to store table data, and each table is stored in its own segment in the table space. So out of all these options, the ones we'll be going with are options A, B, and E. Question 12. Which Oracle process is responsible for recovering a failed user process? A, SMON. B, PMON. C, DBWN. D, CKPT. SysMon or System Monitor process is responsible for instance recovery, but it does not handle cleaning up failed user processes. The PMON, or process monitor, is responsible for cleaning up after a failed user process. So what it specifically does is that it cleans up the resources held by the failed processes, such as releasing memory and blocks. It rolls back any uncommitted transactions, and it notifies other processes about the failure. In option C, the database writer process is responsible for writing modified data blocks from the buffer cache to the data files, but it does not handle user process failures. And in option D, the CKPT or checkpoint process updates the control file and data file headers to mark a checkpoint in the database. However, this is not related to recovering failed user processes. So our answer from these options is option B, the process monitor. This is what is responsible for recovering a failed user process. Question 13. What does the alter system command do in Oracle? A. Alters table structures. B. Creates system users. C. Deletes system metadata. D. Configures initialization parameters dynamically. In option A, to alter table structures, the alter table command is used and not alter system, like we have in the question. In option B, creating system users is done using the create user command and not the alter system. In option C, alter system does not delete system metadata. It is used to modify configuration parameters, but not to delete data. And in option D, the alter system command in Oracle is used to dynamically modify system parameters in the Oracle database without the need to restart the database. It is commonly used to change settings for the database instance, such as login, memory allocation, or session management. So our answer here is option D. The alter system command configures initialization parameters dynamically. Question 14. What is an Oracle tablespace? A. A logical storage unit for storing data in the database. B. A physical data file on disk. C. A backup of the database schema. D. A utility for managing users. An Oracle tablespace is a logical storage unit within an Oracle database that groups together related logical structures like tables and indexes. It provides a layer of abstraction between the physical data files and the database objects, thereby helping to organize and manage data storage. In option B, a tablespace is a logical construct and not a physical file. So the physical data files on disk are associated with the tablespace, but these are not the same things. In option C, a tablespace is not a backup, it is used for storing data. Backups of the database schema or data can be done using tools like the Recovery Manager. And in option D, a tablespace does not manage users. User management is handled through create user, alter user, and similar commands. So out of these options, our answer is option A. Some key points you also need to know about tablespaces is that it consists of one or more data files that can physically store the data, and it is also used to manage storage, control data access, and distribute data across multiple disks for performance and recovery. Question 15. Which Oracle utility is used for database backup and recovery? A. SQL Plus. B. Data Pump. C. RMAN or Recovery Manager. D. OEM or Oracle Enterprise Manager. SQL Plus is an interactive tool used for executing SQL queries and managing Oracle databases. However, it is not used for backup or recovery. Data pump is used for high-performance data migration and export-import operations, but it is not used for backup and recovery. RMAN, or Recovery Manager, is the Oracle utility used for database backup and recovery. It is a powerful tool that helps you create backups of the database, restore and recover data, and perform point-in-time recovery. It automates backup processes and integrates with Oracle's flashback technology to ensure data consistency and effective recovery. The OEM, or Oracle Enterprise Manager, is a web-based management tool used to monitor, manage, and administer Oracle databases, but it is not specifically used for backup and recovery. So out of these options, we'll be going with option C, the Recovery Manager. Some key functions of the Recovery Manager also involves performing incremental backups and compressed backups, restoring the database to a specific point in time or recovery target, as well as backing up and restoring data files, control files, and archived redo logs. This brings us to the end of the practice questions for Oracle Database Administrator 1. Don't forget to like, comment, and share, and also hit the subscribe button so that you'll be informed when our next video will drop. Thank you for watching, and I'll see you in our next video.